Hey, what's up guys? In this video I'm going to be checking out the Scream by Cytomic, and for lack of a better term, this plugin is freaking awesome. And it is designed and developed by Andrew Simper, who has a lot of knowledge in DSP. And when I heard on KBR that he was developing a guitar pedal emulation, I thought it was a pet project or something. I didn't know the scope of what was actually going to be possible with this plugin. And I'll just kind of briefly go over what it is, and I'll just open up the trial here. It is a guitar pedal, and you might not think that's special because, it's a guitar pedal, whoop-de-doo. What makes it special, and the reason why I have the schematic open, is that you can modify anything in this schematic, any component, you can modify things. Really cool, and I've never seen this before. It's really awesome, and yeah, it's exciting. And this stems from communities and guides online where it allows you to modify your guitar pedals, switching out different capacitors, different diodes, replacing op amps to achieve a different tone, and expressing yourself that way. Um, and this is what that is based off of, and it's really crazy and really cool. So let's look at this here. So by default, it's a guitar pedal, and I have my Cerami bass line here, and you can have drive and tone and level. Right? You can do all those fun things, but you owe it to yourself to open this up and modify things. And I'm going to be looking at the schematic here. So I'm not an electronics engineer. I can barely say it. But I can kind of figure out what's going on, and I don't know. There are people that can, look at this and recreate it with their eyes closed, but I can kind of like figure out what's going on. And, looking at this, you got to like understand a couple of fundamental things, and mainly you look at this from left to right. You have your input, and then you have your output, and what happens in between this is what is affecting your sound. Your input is the guitar signal, or whatever it is, right? Let's just pretend that it's a guitar for now, and the input signal is a sine wave, right? And then this is a sine wave, right? And in order to understand what's happening further on down the line, we have to understand that what a sine wave is. A sine wave is something that does that, and up here is positive voltage and then negative voltage. And a sine wave could be 1 volt, it could be a million volt, positive to negative. It's just pushing and pulling, right? And AC, alternating current, is essentially a sine wave. And it's in your walls, it's in the power lines, and that's how they transmit things long distances. And it's really efficient, and that's AC. And this it's important to keep in mind that the signal is AC during the whole schematic process. There is an alternative to AC, which is DC. DC is, so say this is the zero. So this line right here is zero voltage, right? And over here, where my pencil is called the zero crossing. It crosses from positive to negative, right there. That's also very important. DC is just that. It's a straight line, and it's just positive, and that comes out of your iPhone charger and things like that. So that's DC, and it's really good for electrocuting elephants. And I hope that if you understand that reference. I don't condone electrocuting elephants. Anyway, so from left to right, the signal flows, and what's in between it affects things. So understanding this is, we have to understand kind of what's going on here. The components in bold are the components that are readily modified, right? In theory, modifying any value here, any value at all, would have an effect on the signal or the voltage or the bias or whatever. But we're just going to focus on the bold ones. So voltage here, bias, right? Drive, let's do that. Tone, level, and diode 1 and diode 2. Oh, and then this capacitor here. So I'm calling things diodes and other things. There's a bunch of different kinds of uh, like, components used in circuit design or circuits in general, and they're represented by these symbols. So I want to back up here. So before I continue, I want to kind of explain that drive, tone, and level are dictated here. So, but these are still the value you're able to change via a potentiometer, which is a variable resistor. And the squiggly line, right? This squiggly line here, right, is the symbol for a resistor. And what a resistor does is it just, resists the flow of electrons and turns them into heat. So it'll basically, uh, you know, lower the voltage or do something rather, and then in combination will affect things. And looking at a resistor, the resistor will, add resistance. And if you have things happening, like in our drive section here, and the resistance is high on one part, electrons will flow to the path of least resistance. And I'll explain what that means. So you have the squiggly line, which is the resistor. This squiggly line right here with this symbol goes around, right? That is a variable resistor. So these resistors over here, this one, this one, this one, are variable, not variable. Sorry, they're set in their value, and their values are in ohms, right? 10K, 1K, 1 ohm, 2 ohm. They're in ohms, which is their ability to resist electrons. If it is variable, which is a knob, a potentiometer, something that you're able to adjust this from. This one, for example, is a 5K from very low to 5K. You can adjust that value, so you'll get a different resistance depending on where the knob sets. So, and I'm going to get into that because that's how the drive section works, and that's how we're going to better understand what the diodes are doing. There's that. Another symbol that you'll run into are these two things right here. This is a capacitor, and there's different kinds of capacitors, but these are just basic capacitors. They're not polarized, and what they are is they are essentially little batteries. They hold a charge, and yeah, they just hold a charge. And when you pair that with a transistor and things like that, it'll just discharge things. And you can get capacitors to do some really cool stuff. In the audio world, capacitors are really good at filtering, and we're going to get into that, changing this capacitor to filter some things out. These lines right here are voltage, right? So that represents voltage. This is 9-volt voltage. That's DC. That could be from a battery or a wall wart. These right here are ground, and yeah, there's a few of them. That's ground, so not really applicable to anything that's going on here, but it is important. These things right here are transistors. These two things right here are ICs. They're basically a circuit within a circuit, or like an integrated circuit, which is they're like those little black things that are square. They have like circuitry inside them that are kind of complex. These are called op amps. And these basically amplify the signal. They do some really cool stuff as well. And that is essentially it. Besides these right here, now these are diodes. These are what are going to shape the sound, the sine wave, the distortion. And I want to move on to this section here because I really want to get into that, the drive section. So this here, for ease of use, is the drive section. And we need to look at this right here and this right here, these two diodes, and this drive potentiometer here. So we have I'm going to explain what a diode does. A diode only allows the flow of electrons to happen in one direction. So this one, you notice, is the arrow's pointing this way. This one, the arrow's pointing that way. I'm just going to kind of explain what's going on here. So we have a diode here. The diode, right? So it allows signal, for the most part, signal to go in this direction, like that, and then it blocks it coming back in this direction. So when a sine wave, that's the weirdest sine wave ever, it's allowing it to go, in this direction, positive, right? This is positive, so it's going in this direction when it's above the 0 volts. But then as soon as it goes into negative volts, it wants to go that way across that wire. So it's basically not letting this second part of the sine wave, so it's basically cutting that off, right? All right, so it's cutting that off, and you're getting a clipped signal, and this is happening on the lower end of the sine wave. Conversely, if we had another one going in, let's say, oh my God, where am I going? Yeah, this way. Got confused there for a sec. We have another one attached to this same wire. It would allow this to go through, but then it would cut this part off, right? So what's happening is an alternating current is traveling through these two diodes, right? Like that. Guitar pedal, whatever it is. And, this one is affecting the low end. This one right here is affecting not the low end. This one is affecting the positive part of it's clipping the positive part of the sine wave, for lack of a better term, and this one is affecting the lower part, right? So it's basically clipping, essentially. And when a diode prevents things from going, backwards, it's blocking it. It's called reverse blocking. And there's diodes within your iPhone or Samsung charger that are in series. So it's a bridge rectifier, and it's basically so yeah, you have your signal here, right, like that, and when it's gone through a rectifier, or a diode, I should say, a diode, it'll be like that, right? It'll cut that off, and then another one will basically, it'll be fed into a capacitor, which is like a battery, and that'll hold a charge, and it'll be converted to DC. But I didn't explain that well, but it's beyond the scope of this video. You just have to understand what's going on here. So what the drive potentiometer is doing is, like I said, resistors will resist the flow of electrons. And you'll notice that, I'll show you, we have, I'm going to do this in such a way. So we have our signal here, right? Sine wave, and it's going into 2 or 3 things. We'll do that, 3 things. Right here, up at the top, right, is our drive which is a knob, right? And then that is being, fed into, um, the next thing in line. Over here is our rectifier circuit, or not a rectifier, our diode, I should say. And over here is another one, right? So these are in series, and they're all connected. The flow of electrons wants to move over here. It wants to go over here, and it's going to do that in the path of least resistance. So if it gets up to here to these diodes, and diodes need a particular voltage for a signal to go in the positive direction, right? That's why a lot of diodes sound different, I should say. And, it'll go here, it'll be like, okay, what's this, resistor at? If it's like really low, like if the drive is low, then the signal will just be like, oh, I'll just go through the drive, right? I'm actually gonna draw that down here. So if there's the drive here and the drive is has a low resistance, the flow of electrons will just bypass it and it'll continue on its merry way, right? But if it gets here and oops, come on. If it gets to this drive and there's a lot of resistance, like 5K resistance, it will essentially slow down, right? But then there's all this information coming, or not information, electrons coming this way. It can't go past here, so then it'll be like, all right, to hell with it. I'll go through these rectifiers, right? And you can demonstrate that. If you go to, here, right, you will, you will, with the drive at a very low resistance, it will pass through, but as we increase, more and more of it will go through the diodes here. And, the capacitor is here to achieve a bit of, continuity and smoothness between here, for lack of a better term. Right, so at 100%, it's at 5K, or it's not quite at 5K, but yeah, it's basically slowing these down so then they go through the diodes here. So, spoken enough about diodes. So, what is the point of looking at these things here? So, common modification is changing these diodes, and there's a bunch of diodes. There's silicon, and there's germanium. LEDs. An LED is a diode, but an LED requires more of a voltage positive in the direction that they go. They require more in order for them to become, engaged. You get more of a distortion across the zero crossing, or not so much of the zero crossing. Hard to explain. But different LEDs have a different sound. You can add in an LED and get some neat distortion like this, right? And I mentioned before there's these two diodes here. One affects the top end of the sine wave, and the other affects the bottom end. So what you can get is something called asymmetrical clipping, where there's a different clipping at the bottom end of the sine wave than the top. And this can seem to be a bit more warm. Oh, I might want to turn on the mod, sorry. Right, so you have to turn on the mod here. I totally forgot about that. But yeah, we have different diode types here. And we can match them up in series. We can have more than one diode occurring instead of just one. We'll get 2 or 5, and that's just further protection of reverse blocking. It doesn't reverse block 100%, but it'll make the clipping more intense. And I'll give you an example. Right, things like that. So keep that in mind. Oops, get that trial open again. So common mod is adding in a 1N914, I believe. And you know, with that, germanium is a little bit more tube-like, a little bit more warmer, and Zener diodes are, I think they're a little bit more intense. They have an interesting color. I have a couple of them. Right, things like that. So that is, in a nutshell, the diode section. And I might do an oscilloscope kind of a demonstration of what's going on there, because that, with the bias and all that fun stuff, it's just really cool. And you know, for a layperson like me, it's really exciting. So yeah, let's look at this. So I reset that. The next modification is the high pass capacitor, and this is another interesting mod. The C103 is right there, right, and it's receiving voltage from this right here, 4.5, sitting there. So this is the little battery that's being fed into the drive. Um, you know, just catching and smoothing out the AC as a little battery, which is pretty cool. So with that, what we can do is we can adjust the high pass being fed into the drive, right? And there's a bunch of common mods right here. 4.17, the N, the U, and things like that. There's nanofarad, and there's picofarads, and there's puff, and things like that. They're just values of charge. But yeah, this is these are common mods: DX plus, and then the DX hot, and the DX turbo. You can do all sorts of things with that, and that's being fed into the drive. And you know, we can have it like really low as well. And yeah, it's represented in frequency, which we kind of understand. So yeah, 720 hertz bump, which is 808, and 304 hertz. Things like that. You know, it's all fun and dandy. The next one is the low pass, which is right here. And this is being fed into the tone, which is a different, which is another variable potentiometer, or like a variable resistor, I should say. And it's this knob right here, which is adjusting the tone of the sound. So with that being said, we can change this and get a different kind of tonal quality to it. Right, we can make it sound brighter, darker, by increasing the value here. Things like that, which is pretty fun. Right, so the next kind of mod is the mod for these guys right here. Now these are ICs, these are op amps, and these ones are inverted, I believe. So there's a positive and then a negative and then an output. And yeah, these do some magic, and there's a lot of complex stuff happening within them, but you don't really need to know everything that's happening within them to have a general idea of what's going on. Op amps have something called a slew, and that is their reactiveness to distortion. And they have different kind of ratings, I guess. So this is when something's being pumped into it. I'm just going to explain it how I how I have, how I think it might occur. When a sound is pumped into it, it takes a little while to react to that. And they're in ratings of volt per second. So this is like, microsecond. Oops. So the amp slew will basically switch out the op amp. And like there's different op amps for different uh, applications. I think the LM147 is quite famous. But yeah, we can adjust this and get a completely different sound. I like that one. And yeah, that's basically what you can do with the, I guess you say like the readily made and available um, uh, the components that you would commonly mod. So with that being said, I want to maybe touch on the voltage here. So what the voltage does is, like I said, the heart of what's happening here are these diodes. And these diodes actually have a minimum requirement of voltage to go across them, especially the LEDs. So if we drop the voltage, they will not, say we have a sine wave, right? Right. The voltage, even in the direction that it wants to go, right? It's allowed to go in, will not trigger until it's about here, right? So you'll get like this super fast jump from 0 to whatever positive or negative value it is. And yeah, that's done with essentially dropping the voltage across this. So I'll just give you an example of that, and you can get like a really interesting sound that way. Right, you can get something like super brittle. Right, and you can get some really cool stuff with that. And yeah, depending on the diode that you're using, you'll get a different effect. The LEDs, I'm just fascinated that LEDs can do this and things like that. So another one is the bias. This one's also important. And what the bias is, okay, so we have, these two diodes here, right? They do a thing to a sine wave. One will cut off this certain point, and another one will cut off this at a certain point. And then there's like the 0 dB thing right here. So this and then this. What the bias will do is it will actually shift up the sine wave in general. So on the positive sine wave, you'll get like a more extreme cut here, and then down here you'll get like a gentler cut, and it'll kind of shape the sound that way. So if you have you'll have more of a distortion on the negative voltage on the sine wave than the positive, or vice versa. And this adds more, asymmetrical clipping kind of thing going on. So I'll give you an example. Right, and this would be better looked at in an oscilloscope, but whatever. So we have this here. We'll just shift the bias up, and we're moving the sine wave up. So, the positives are more positives, and the negatives are less negative. Right. So yeah, with the diode in the bottom, I'm getting more of a a low end sort of thing, and up here, oh wait, that's voltage. Never mind. And it really depends on the diode that you're using. And this is better explained and looked at when we're checking out the oscilloscope, which I want to explore and look at a little bit more. So That was poetry. So yeah, that is the Scream explained by, you know, a guy on the internet. Really cool. The one of the latest versions, you can actually see the schematic within the mods, because right now it's just a list of here, and the list is in order of the signal path, which is cool. But you know, seeing it within the actual, you know, in context would be super valuable and awesome. But yeah, that'll be soon, I imagine. Anyway, I hope you guys enjoyed that video. I hope you learned stuff. Take care and have a good one.